Hello, I'm Mrs. J, and we're going to work on polynomials of higher degrees. And so when you're looking at polynomials of higher degrees, the first thing, if you have x to an even power, then it's going to resemble a parabola. It's either going to go up or down with a couple bumps in between. Now, let's put a letter in front, put our base. If a is greater than 0, it goes up. If a is less than 0, it goes down. If y is odd, then it looks like the snake function. And when it's positive, a is greater than 0, it's going up. And when it's less than 0, it's going down with some bumps in the road. When we have this value, the number of turns or bumps is b minus 1. So if it's ax to the 5, then at most it will have 4 turns in it. 1, 2, 3, 4. 4 max and mins. Let's look at some of the things. So if we look at the first graph, then we have the main thing you're looking at is negative 5x to the 6th. It's even, so it's a parabola. It's negative, so this parabola is going down. So falls to the left and rises to the right. Well, that's definitely not right. It doesn't rise at all. It falls to the left and falls to the right. So you would mark this one. Both ends are going down. Okay, let's look at the next one. B. Okay, so in this one, negative 5x cubed. So it's odd, which means it looks like a snake. It's negative, so instead of going up, it's going to go down. So that means it rises on the left and it falls on the right. So that would be this one. Now the last one, notice the 5 in the front is positive, but then when you're trying to find the degree of the polynomial, because the degree of this one is 3 and this one is 6, this one's not multiplied out. So we have 5x squared, 3x plus 2, and x minus 5. Well, this is x to the first, and this is x to the first. So 2, 3, 4. The degree of this one is 4. If you multiplied your first terms together, you'd have x to the 4th. So the degree is 4, and these terms are positive, so it's a parabola going up. So our degree was 2, 3, 4. And the leading terms are positive, so it's a parabola going up, which means it rises on the left and the right. So it would be this one. Let's try one more. Okay, so this is even, means it's a parabola. This is positive, so it's going up. So it rises on both sides. This one is the snake. It's negative, so it's going down. So it rises on the left and falls on the right. The last one, we have x times 5x, which is 5x cubed, which means it's a snake. This is positive, so it's going up. And so it falls on the left and rises on the right. It would be the first one. Inferring properties of a polynomial. Okay, on this one, okay, so when we look at this one, we know it's both going up, so it's an even function. But they want to know that the function is decreasing over which intervals. Well, if we look at this, it's decreasing from negative infinity to negative 4. And then it starts increasing. Now when you're doing this, you're going along the x-axis. So it increases from negative 4 to negative 2. It's going up. Negative 4 to negative 2. Then it starts going down again from negative 2 until 2. And then it increases from 2 to 6. And then it decreases again from 6 to 8. And then after that, it increases, and it keeps increasing from 8 to infinity. So you're going along here. From here to here, it decreased, and then it increased, and then it decreased, and then it's going up, then down, and then up again. And so on this one, we'd want, you mark all that apply. So it would be negative infinity to negative 4, negative 2 to 2, and 6 to 8. You'd mark all three, because they wanted decreasing. The function f has a local max at what x values? If there's more than one value, separate them by commas. Okay, so we have local max at x equals, and we'll do the min at the same time just for some practice. So if you look at this first one, this low point, where the increasing and decreasing change, it's at negative 4. And since that's a low point, it's a local min. Then where the next increasing and decreasing change is at negative 2, and that's a high point. So that's a local max. Then this one is a min at 2. Notice it's always where increasing and decreasing change. It's 2. And then up at 6 is another max, because it's a high point here. And one more min at 8. So those high and low peaks are the mins and max. What is the sign of the leading coefficient? Well, notice both ends are going up. So it's a parabola, which means the degree is even. And since both ends are going up, for part C, leading coefficient is positive. If both ends went down, it would be negative. And then it says, which of the following is a possible degree? Well, we know it's even because both ends are going up. It has to be even. That's a parabola when the degree is even. And we know there are 1, 2, 3, 4, 5. There's 5 maximins. So the degree is 5 plus 1 and every even after that. So 6, 8, 10, 12. So in this case, it would be 6 and 8. Let's try another one. Let's get an odd one. No. Okay. So on this one, increasing and decreasing. So the graph starts out always left to right, it's decreasing. So from negative infinity until negative 6, it's decreasing. Then here at negative 6, it increases until negative 4. So negative 6 to negative 4. And then from negative 4 to negative 1, it's going down. And then it increases from negative 1 to 3. Then at 3, it starts decreasing until I hit 6. And then at 6, it increases until we hit 8. And then at 8, it keeps going down. So it decreases from 8 to infinity. They wanted decreasing, so you would mark these 4. On a test, I would ask for all of it. So. The function f has a local maximum at which x values? If there's more than one value, separate them by commas. Okay, the maximins. So the first one here, we have a min. You're looking where your increasing and decreasing changed. It's all these endpoints. And so at negative 6, there's a min. There's a max at negative 4. And we go over here, there's a min at negative 1. And make sure you're always using the x values. And then we go up until we hit here. So there's a max at 3. A min at 6. And a max at 8. They wanted the maximums, so at negative 4, 3, and 8. And then the sign of the leading coefficient. Okay, it's going like this. So it's decreasing. That means it's a negative. And because it looks like the snake, the degree is odd. Which of the following is possible for the degree? Well, we know it's odd. Now count your maximins. 1, 2, 3, 4, 5, 6. It's going to be 6 plus 1 and every odd after that. So 7, 9, 11. So what's those called? Inferring. One more. Determining the end behavior of a graph of a polynomial right here. Okay. Wait, we did that one. 1, 2. Determining the end behavior and intercepts. They added a little bit to it. Determining, I think it was up here. Here it is, and intercepts. That's one I want. Okay. So considering this polynomial, the degree is 3 because there's 2 here and 1 here. So our degree is 3. Answer the question regarding the choose the end behavior. Okay. Well, we said the degree is 3 because this 2 and this 1 makes it 3, which means it looks like a snake. The leading term is positive, so it's going like this. So to the left, it's going down, and to the right, it's rising. List each real zero. Okay, when you're listing the zeros, you're setting them equal to 0. So we have f of x. If we set this equal to 0, we get a -1. If we set this one equal to 0, we get a +1. So these are our zeros. Now, it's also asking if it crosses or touches. It crosses if the multiplicity is odd. It touches if it's even. The multiplicity is the exponent. So the exponent on this one is a 2, which is even, so it touches. This one, the exponent is a 1, which is odd, so it crosses. The y-intercept you just let x be 0. So if we plug in 0, we have 1 times -1, which is a -1. So to graph it, we have our y-intercept at -1. We know it crosses at zeros are x-intercepts. So here at -1 and at 1. But at -1, it's even, so it touches. This one had odd, so it crosses. We know the degree is 3, so it's going like this. So it's going up, it's touching here, going down and hitting here, and then it's crossing. And there's our graph. So by following the rules you just learned and marking your x-intercepts, you can get an estimate of what the graph looks like. Now it could keep coming down here some and then go up. But it will resemble this. Try one more. Okay, so we have 1, 1 and 2. So our degree, 1 plus 1 plus 2, the degree is 4. That means it resembles a parabola. This one's negative, so that means it's going down. So for our end behavior, both ends are going down. That would be part A, both ends going down. Then they want to know what the zeros are and if they cross or touch the x-axis. So our zeros, setting this one, we get 0, -1, and -2. So it crosses the x-axis at 0, -1, and -2. Now, multiplicity is the exponent on it. This one was odd because it was 1. So it crosses. This one's also 1, so it's odd. It crosses. This one, the exponent is even. It was a 2, so it touches. So this one goes with the touching, and these two go with the crossing. The y-intercept, you let x be 0. Almost every graph you're going to graph, you'll find a y-intercept because it's an easy one to find. Plugging in, we have -0 times 0 plus 1 times 0 plus 2, which is 0. Graph it. Y-intercept is 0, 0. It also crosses there because it happens to be an x-intercept also, but it crosses. So I'm going to put a C for cross. And then at -1, it crosses, and at -2, it touches. The graph's going this way, so it's going to come up. It's going to touch this, then it's going to come down, but then go to the next one and go through, and then it goes through there, and there's... I know it's not coming back up again because these are the only 3 spots where it crosses the x-axis.